So this is the Unit 1 test review, and these are the AKS IOAs that it's covering, basically proving simple geometric theorems algebraically and operations with polynomials using a geometric context. So this has to do with slopes and distance formula, midpoints of quadrilaterals, that be parallelogram, rectangle, rhombus, square. And then operations with polynomials, where we're using polynomials that have polygons that have polynomial side lengths to find perimeter and area. Okay, so here's our first problem. Given the following diagram, what are the slopes of the lines, and classify the pairs parallel, perpendicular, and either. Okay, so what we're going to do is we're going to look at these lines, and on y'all's papers, we went ahead and put in that this was A, and this was B, and this was A, and this was B. Okay, so let's see if we can find 2 points on A and 2 points on B, and see if we can figure out what the slopes are. So here's a point that's on A, and there's another point that's on A. Y'all see that? So we can go up 1, 2. So slope of A, 2 up, and 1, 2, 3 over, 2/3 over, right? So the slope of A was 2/3. Let's do the same thing with B. Let's see if we can find another point. So here's a point on B, and there's another point on B. And so again, 1, 2 up, 1, 2, 3 over. So the slope of B is also 2/3. So what does that mean? That means that A is parallel to B. Sorry, line A is parallel to line B, right? So they are parallel, and I'm going to write that. Okay. Then we have A over here on the right. So we're going to do the same thing we did a minute ago. This time, I can tell, first of all, that it's negative because it's falling from left to right. Can you guys see that? I'm going to move this A up a little bit so that it's kind of out of our way. All right, so we're going to do the same thing here. So I got a point there that's on the line, and then I got another point right there. Y'all see that? So when I'm talking about the slope of A, I'm going down 1, 2. So down 2 and over 1, 2, 3 over 3. So that's the slope of line A. We're going to do the same thing with the slope of line B. Okay, so here again we got a dot right there, and we got another one right there. Y'all see that? So here we go. 1, 2, 3 up, and 1, 2 over. Okay, so what do you notice about those slopes? One's positive, one's negative, first of all. And one of them is 2/3, the other one's 3/2. So they are reciprocals of each other, and that's what we call negative reciprocals. So what that means is that line A is perpendicular to line B, right? So this is perpendicular. Okay. That doesn't look very clear. Perpendicular. All right. Then it says, given the equations 5x minus 2y equals 1, find the equations of the line that pass through point 10, -3. Okay, so it's asking for us for the parallel line and for the perpendicular line. So the first thing I want to do is take this equation right here, and I want to see if I can solve it for y. So I'm going to do that first. So I'm going to just rewrite it first. 5x minus 2y equals 1. So I'm going to subtract the 5x from both sides. So that's going to give me -2y is equal to -5x plus 1. Then I'm going to divide everything by 2, or excuse me, -2. Right? So that's going to give me y equals 5/2 x minus 1/2, right? So what is the part of this that we care about? The slope, right? So we only care about the m right there, right? So if we're talking about a parallel slope, then m is going to be equal to 5/2. And then when we talk about the perpendicular slope, this is going to be our perpendicular m. That's going to be equal to -2/5 because we change the sign and we flip it, okay? So let's continue on, and let's see if we can figure out the rest of this. Now remember, we're going to use the equation y equals mx plus b. Well, we have our m right here. But we need x and we need y because we need to solve for b. So there's our x right there, 10 right up here, and y. So over there, see that where it says through the point? So x, y. So our y is -3, and our m is 5/2, and we're going to multiply that by 10, and we're going to add b. Now, I know that 5 times 10 is 50, divided by 2 is 25, so this is going to be negative 3 equals 25 plus b. So we're going to subtract the 25 from both sides, right? So that's going to be negative 28 is equal to our b. Now, what do? We plug the b and the m. Here's our m, there's our b. We plug those back into the equation. So y is equal to 5 halves x minus 28. There's our answer. Now, same process over here. We're going to take our y again, which is negative 3, and that's going to be equal to our m, negative 2/5, times our x, which is 10, plus our b. So again, negative 2 times 10 is negative 20. Negative 20 divided by 5 is negative 4. So this is going to be negative 3 equals negative 4 plus b. We're going to add 4 to both sides. So b is equal to 1. Now, once again, we are going to plug in our m and our b into our equation, right? So y is equal to negative 2/5 x plus 1. All right, some more of the same here. So go ahead and do this one. Come back to me when you're done. So here again, we have this equation, and it says when placed on a coordinate plane, Main Street has an equation of 2x plus 8y equals 5. Park Street is perpendicular to Main Street. So this one is perpendicular, right? And Main Street, perpendicular to Main Street. Tower Street is parallel, so this one's parallel, okay? So Park and Tower both go through the point 3, negative 5. Okay, so we're going to talk about how this works. So what we're going to do first is take this equation and solve for y again, okay? So I'm going to do that. I don't know why it moved, but we'll move it right back up there. So we've got our 2x plus 8y equals 5. So we're going to subtract the 2x from both sides, right? So that's going to give us 8y equals negative 2x plus 5. Divide both sides by our 8. So that's going to be y is equal to, that reduces to be negative 1/4 x plus our 5/8. Don't even care about the 5/8, right? What do we care about? The m, right? So our m is right there, isn't it? So when we're talking about our parallel slope for Tower Street, m is going to be equal to negative 1/4. When we're talking about the perpendicular m, that's going to be positive 4, right? Now remember, again, when we're doing our x and our y, there's my x, there's my y. We're going to once again use the equation y equals mx plus b. Our y is negative 5. Our m is 4 here. Our x is 3. And we're adding b, right? So it's going to be negative 5 equals 12 plus b. We're going to subtract the 12 from both sides. So b is going to be equal to negative 17. In our equation, remember, what are we plugging in? M and b. Okay, so y is going to be equal to 4x minus 17. Okay, so then we're going to do the same thing for parallel that we just did. So this is going to be negative 5, that's my y, is equal to this time negative 1/4 times our 3 plus our b, right? So this is going to be negative 5 equals negative 3/4 plus b. We're going to add 3/4 to both sides. And you can do this right in your calculator, right? So that's going to give us a negative 4 1/4, isn't it? That's equal to b, which is also equal to negative 17/4, right? Or 4.25. Doesn't matter which way. I mean, it could be written any one of those ways, right? So once again, notice that we got our m here, and we've got our b's here. However we want to write those, I'm going to write it as an improper fraction. So y is equal to negative 1/4 x minus 17/4. All right, the next problem says choose which properties apply to each quadrilateral. Choose all that apply. Before we get going on this, I want to talk to y'all about a couple things. If it says consecutive sides, this means right next to. And perpendicular means right angles, right? So what shape has right angles? That's what you're going to ask yourself, okay? And then down, all sides are congruent. I think you know what that means. Diagonals are congruent. So the shapes that have diagonals that are congruent are the shapes that have right angles. And this is a way for you guys to memorize it, okay? It's a handy piece of information, okay? So now let's just talk through the rest of these. A rectangle. Actually, let's talk about the properties. Opposite sides are parallel and congruent. That's all of them, right? Because they are all parallelograms, yes? Okay, then we've got diagonals are perpendicular. So that's a property of a rhombus, and guess what else? Other shapes of rhombus is square, right? So we're going to work through these one at a time. Then we've got consecutive sides are perpendicular. So what shapes have right angles? That would be our rectangle and our square, right? Then we have, let's find a different color here. I'm going to pull an orange. How about that? All sides are congruent. I think you know that that's a square and a rhombus, right? Diagonals are congruent. Again, think about the right angles. What has right angles? Our rectangle and our square, right? Okay, so this is going to be E, and this is going to be E. And then we have one left, and that is diagonals have the same midpoint, right? So let me mark through that first, and I'm going to get us a purple here. So diagonals have the same midpoint. That applies to parallelograms, so that means it applies to all of them again, okay? So this is F, 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 and F. Now, I'm going to suggest that you guys, when you're studying, that you cover up. Let's see if I can show you what I would do. Let me do this. Okay, so I would suggest y'all cover up this side over there, and you go ahead and write your shapes underneath here and see if you can remember. Or at least, you know, write it on a separate sheet of paper so you can study, 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 okay? That would be my recommendation. So now we're going to find the midpoint, which means we're going to add our two x's together and divide by 2. We're going to add our two y's together and divide by 2. So we're just doing 2.5 plus 5 divided by 2, comma, negative 3 plus 1.5 divided by 2, right? So 2.5 divided by, or plus 5, or plus 0.5, sorry, that was supposed to be a 0.5, y'all. 0.5, that's going to be 3, right? 3 divided by 2. And then negative 3, that's going to be 1.5 divided by 2, right? So if we simplify this one step further, this could be 1.5 and 0.75, right? Oh, and that's a negative. Y'all notice that? Common error right there. Boom. Almost made it myself. So double check that stuff, right? Because if the bigger number is negative, then the whole term's going to be negative, yes? Okay, let's do it again. So we're going to do 8 plus 2 divided by 2 and negative 1 minus 7 divided by 2. Notice I don't add a negative because adding a negative is just subtracting. So this is going to be 10 divided by 2. This is going to be negative 8 divided by 2. So this is going to be 5 comma negative 4, isn't it? Okay, got another one over here. 0 plus 1.5 divided by 2. And then we have 6 plus 4 divided by 2. So that's going to be 1.5 divided by 2, comma, 10 divided by 2. So that's going to be 0.75, comma, 5, right? That's all you're doing there. We did pretty good on the quiz on that. We'll see how we do on the test, right? Okay, then down here it says, are the points J, K, L, M, the vertices are parallelogram, rhombus, rectangle, square, or just a quadrilateral? Explain using the properties. Okay, so we're going to go ahead and draw these lines. J, L, M, L, M, J, J, K. Okay, so now we're going to talk about what we see. So, looks like it could be a rhombus, but that would mean all the sides would be equal. So we're just going to look at some side lengths. So let's just look at JK. We can see it's falling. So that's a negative 1 right there over 1, 2, 3, 4. So that's negative 1, 4. So JK's slope is a negative 1 over 4, right? That means, let's look at ML just to make sure. Because this one also is going down 1, right? Down 1 and over 4. So those would be equal, right? So that would also be ML slope, okay? Now we're going to talk about JM. JM is 1, 2, 3, 1, 2, 3, 4, up and 2 over, okay? So JM slope was 4 up, 2 over, right? So that's 2. And is that the same over here? 2 over, 4 up. Yep, 2 over, 4 up. Y'all see that? Okay. So that means that both of these, JM and KL, are the same slope, right? Those are the slopes of both. Okay, so what do you notice? These are not negative reciprocals of each other, right? So this can't be a rectangle or a square. And let's check and see if it is a parallelogram, okay? So, or I mean a rhombus. So if I do negative 1 squared plus 4 squared, and I take the square root of that, that's 1 plus 16. That's the square root of 17, right? Let's compare that to our original numbers for the other one. 4 squared plus 2 squared. I would dare say most of y'all can already see that those are not going to be equal. 16 plus 4 is the square root of 20. So this is going to be a parallelogram, right? Because opposite sides are parallel and congruent. And you could also determine that the midpoints are the same, right? Because that's the other property that we know, okay? So then our next one is A, B, C, D, the vertices. What we're asking us again, what is this shape here? So there's A to B, B to C, C to D, D to A, okay? So let's see what we can see about AB. AB is rising from left to right, so we can see that. So it's going 1, 2, 3, 4 over, 1, 2 up, right? So this is 4, so this is 2 over 4. So AB is equal to 2 over 4, which is equal to 1/2. And if we were to find that side length, remember again, we're doing 2 squared plus 4 squared, right? So isn't that going to be the square root again of 20? It is, okay? Now let's look at BC. And by the way, can you guys see that this is the same right here? 2 up, 4 over. 2 up, 4 over. Those are our opposite sides. So that's not only equal to AB, that's also equal to DC, right? Okay, now let's talk about BC. So BC is going up 1, 2, 3, 4, and over 1, 2. So BC is up 4 over 2. That's a slope of 2, right? And you can already tell they're not perpendicular. 1/2 and 2 are reciprocals of each other, but they're both positive, okay? So again, when we look at the length of BC, we're doing 4 squared plus 2 squared. Well, didn't we just do that? We did. So this is the square root of 20. So what have we just discovered? That all 4 of these sides are equal. So this is a rhombus. That's our property. Now there's another property you could have looked into, which are the diagonals. And I'm just going to show you that quick. This is falling from left to right. So 1, 2 down, 1, 2 right. So DB is got a slope of negative 2 over 2, which is negative 1. Now let's look at AC. AC is the other diagonal. 1, 2, 3, 4, 5, 6. So AC is 6 up and 1, 2, 3, 4, 5, 6 over. So isn't that 1? So isn't negative 1 and 1? So we could say DB is perpendicular to AC. That also could have proven that this was a rhombus. Okay. So here's our next problem. It says, given the following points in the graph ABCD, we want to create figures below. Then what should the coordinate pair be for D? Okay, so it's really important here that you guys do the problem, draw this problem in the order that it's here. So it says C, B, A. So we know that D is going to be over here somewhere, right? Okay. So we're going to use the slope. I'm going to use the slope from B to A. So I'm going down 1, 2, 3, and left 1. So right here I'm going down 1, 2, 3, and left 1. So that's where I think point D is. But we're going to verify that with the slope of the other side, right? So this time we're going to go, again, always go from the point where the two sides come together. So it's up 1 over 1, 2, 3. So I'm going to do the same thing I just did a minute ago, only from point A. So I'm going to go up 1 and over 1, 2, 3. Guess what? We got the same point. So D is negative 1, negative 1. Okay? So once again, we're going to draw B, A, C, D. So we're going from B to A and over to C. And once again, don't we know that D's got to be over here somewhere? Exactly. So let's, again, look at those slopes. So I'm going to go again from this point where they come together. So I'm going A down 1 and over 1, 2, 3. So from B, I'm going down 1 and over 1, 2, 3. So that's where I predict point D is going to be, but we're going to check it again. So now we're going to check with AB. So we're going to go down 1, 2, 3, and over 1, 2. So we're going to do that from C. 1, 2, 3, and over 1, 2. Look at that. We got the same point for D, right? And you can finish these shapes, y'all, so you can see that they are indeed parallelograms. And sometimes that'll help you to see whether indeed the problem, whether you got the right point or not too, because if it doesn't look like a parallelogram, then something's wrong. So over here, our point D was 1, negative 2. Okay? All right, so for this next one, it says, given the following points in the graph, find the length of each side and the perimeter to the nearest hundredth. So what we're going to do is I'm going to look at X, Y. I'm looking at this side right here. Okay? So I notice it's rising, right? So it's 1, 2, 3 up. 1, 2, 3, 4, 5, 6, 7. Oops, I can't draw a straight line today. 7. So that's 7. Let's check this one to see if it's the same. 1, 2, 3 up. Yep. 1, 2, 3, 4, 5, 6, 7. Yep. So if we're looking for these two sides, I can see that XY is going to be equal to WZ. Can you guys see that? So what are we going to do? We're going to take our rise and add it to our run. Okay? That's going to give us 9 plus 49, and that's going to be the square root of 58, right? And the square root of 58, if you put it in your lovely little calculator, if I'm not mistaken, is about 7.62, right? Okay. Now let's talk about the other side. Okay. So now we're going to talk about YZ. 1, 2, 3, 4, 5, 6, 7 again. And 2 this time. 7 and 2. Let's make sure this one is 2 wide. 1, 2, 3, 4, 5, 6, 7 again. 7 and 2, right? So once again, we should see that ZY is going to be equal to WX. And that's going to be the square root of 7 squared plus 2 squared, right? So that's going to be 49 plus 4. So that's going to be the square root of 53. And that is approximately 7.28, right? So now what do we do with these two sides? Because it's asking us for the perimeter. That means the distance around the outside of the object, right? So aren't we going to go 2 times our 7.62 plus 2 times our 7.28? You got it. And when I did that, I got 29.8. And I put approximate. Depending on how you solve this, y'all, the answer is going to be approximately that, okay? All right, then it says find the sum or difference, put in standard form. So what I'm going to always do here is I'm going to put them in descending order first. So this is going to be 2y to the third plus 5y squared minus 3y minus 9. Line up your like terms, okay? So I notice I don't have a y to the third, and we are adding these, right? So we're not going to be changing any signs here. So this is going to be 4y squared, and then we got minus 7y, and then we got plus 6, right? So our answer here, again, we're just combining like terms. We didn't have a like term with this, so it comes straight down, right? So this is 2y to the third. 5 plus 4 is 9y squared, right? Negative 3 plus negative 7 is just a bigger negative, right? Keep the sign. And then we got negative 9 plus 6, so that's going to give us a negative 3. Okay, there's our answer for that one. So let's set up the next one. Okay, so when we set this one up, again, we got a 7v squared minus 4v, right? Now, look, we're going to write them in descending order. We didn't have a v to the third, right? So this is 3v to the third. Then we got a minus 9v, and then we got a plus 5. Now, remember, we have a minus sign in this problem, right? So what does that mean we're going to do? We're going to change the signs of everything we're about to do. So we're going to put a plus there. We're going to put a minus in front of that, a plus in front of that, and we're going to make this one a minus. And then we're just going to add them, okay? So we got the 3v to the third. Then we're going to bring down this one, plus the 7v squared. 9 minus 4 is 5v, and then we got a minus 5, right? So there we go. Now don't forget to change the signs of everything, okay? All right, the next one's going to be similar, but a little different. So here we go. We're going to write them in descending order again. So we got 2y to the third plus 5y squared minus 3y minus 9. Now we're going to write the other one as well. And remember, we are going to subtract this one. See that subtraction sign right there? So we're going to be a minus out there, but we're going to go ahead and just write it the way it is. So now we have 4y squared minus 7y plus 6. Now what are we going to do? We're going to change all those signs. So this is going to be a minus, this is going to be a plus, this is going to be a minus, and now that's plus. Bring this right down again. 2y to the third. 5 minus 4 is 1, right? So that's just going to be plus y squared. 7 minus 3 is 4y. And then we've got two negatives now, so that just makes a bigger negative, right? Indeed. There we go. Okay. So we got one more here. We're going to do this one too. 7v squared minus 4v. And this time we're adding, right? So we're going to put our 3v to the third minus, whoops, no, there's no v to the second, right? So this could be minus v to the second, or v, plus our 5, right? Okay, so now, once again, there's nothing like the 3v to the third. Actually, let me do this in blue like I've been doing. So this is coming right down. The next one is also coming down, right? 7v squared. A minus combined with another minus is just a bigger minus, right? And that just stays positive. So there's your answer, okay? So notice the differences in the problems, okay? So this one says to find the product, and I knew it was going to be multiplication anyway because they're both in sets of parentheses, right? So what we're going to do is we're going to put the first one in descending order, 6x squared, 7x, and negative 5, right? Then we're going to do the same thing with this other one. We're going to do negative x to the third. That was my biggest term, right? Then we got 4x squared. And then we got a negative 8x. Notice I put them in descending order because that's going to help me keep things organized. Okay, so when we multiply 6 times, remember there's a negative 1 in front of there, that's going to be a negative 6, right? And when we do this, remember, it's x to the third times x to the second. So what we really do is x to the 3 plus 2. So that's going to be equal to x to the fifth, right? Just in case you don't remember the process. So this is going to be x to the fifth. Then we're doing 7 times negative 1, that's negative 7, right? And then we're doing x to the third times x to the 1, so that's going to be x to the fourth because 3 plus 1 is 4. Then we're just doing negative 5 times the negative 1. Negative times the negative is a positive, right? And so that's just going to be 5x to the third, okay? 6 times 4, that's 24. And 2 plus 2 is 4, so that's x to the fourth. 7 times 4 is 28. 2 plus 1 is x to the third, right? Negative 5 times positive 4 is going to be negative 20, and that's still my x squared. All right, here we go. 6 times negative 8 is negative 48. X to the first times x to the second is going to be x to the third because it's 1 plus 2. 7 times negative 8 is going to be a negative 56, and this is going to be x squared again because it's 1 plus 1. And then we've got our negative 5 times negative 8. That's going to be a positive 40, right, x. Okay, so now let's look at, see if we can find some like terms. So I don't see anything like that one. I do see in the diagonals right there my x to the fourths. I see right here my x to the thirds, right? I see right here my x to the seconds, and then I got another standalone term right there. So I'm going to do negative 6 x to the third, and I'm going to do 24 right here minus 7. That's going to give me plus 17. Oh, sorry, that wasn't x to the third. What was that? That was x to the fifth. I can't read my own handwriting, y'all. That was x to the fifth. So the next one is going to be x to the fourth, right? Then we've got negative 48 plus 28. That would be negative 20, right? Plus, wait. Did I do that wrong? 48. So negative 48 and 28, that would give me negative 20, and negative 20 plus 5 would be negative 15. X to the third. Y'all can do this on the calculator, right? Negative 56, we got two negatives right here, right? So that's just going to be negative 76. x squared, and then we got our standalone right here with our 40x, right? There we go. Okay. All right, same thing over here. We're going to take this term first, negative 6x squared, gone. Then we got a negative 5s. Then we got a 4, right? Okay, then we're going to take this 3s squared, and we're going to do this negative 2s. So here we go again. Negative 6 times 3 is negative 18. We're going to add 2 to 2. That's going to be s to the 4th, right? Negative 5 times 3 is negative 15. 2 plus 1 is s to the 3rd. And then 4 times 3 is 12. And we got our s squared, right? We got a negative 6 times a negative 2. That's going to give us a positive 12. And then 2 plus that 1 is going to be s to the 3rd again. Negative 5 times a negative 2. Negative times a negative is a positive, right? That's going to be positive 10. And then we got 1 plus 1. That's going to be s squared. And then we got 4 times negative 2. That's going to give us a negative 8s. Okay, so do you guys see our like terms again? So we got this one. There's nothing like it, right? Negative 18 s to the 4th. Then we got our like terms right there. So we got a negative 15 and a positive 12. So that's going to give us negative 3s to the 3rd. Then we've got a 12 plus a 10. So that's going to give us plus 22s. And then we got the standalone term again, negative 8s. So there's our answer for that one. Okay, so this next one says, find in simplest form the expression that represents the perimeter of the triangle. So we just have to do what? Perimeter means the distance around the outside of an object, right? So aren't we just going to add these three sides together? We are. So we got 9b plus 8 plus 12b minus 8 plus 12b minus 8. Okay, so I'm just going to add. 2 plus 2 is 4, and 4 plus 9 is 13. So I'm going to add that one there. There's 3. And so this is going to be 33b, right? This plus 8 and this negative 8 cancel each other out, so that's just minus 8. So there it is, the three sides added together. Now number 13 says, if the sides of a square are 5x squared minus 4x plus 4, what is the perimeter? So what do we know about all the sides of a square? They're equal, right? And how many of them are there? 4, right? So we're just going to multiply 4 times 5x squared minus 9x plus 4, right? So 4 times 5 is 20, so this is 20x squared. 4 times negative 9 is negative 36x, and 4 times 4 is 16. That's all you had to do. Okay? So the next one says, if the sides of a rectangle are 9 minus 12d plus 4d squared and 7d squared minus 5d plus 8, what is the area of the yard? So 1, 2, 3 terms, 1, 2, 3 terms. So isn't this going to be a 3 by 3? So once again, I'm going to write this term in descending order. So I'm going to say 4d squared, gone, negative 12d, gone, 9. See that? Then we're going to do 7d squared minus 5d and our 8. Okay? So now, again, we're doing the same thing we just did a minute ago. 4 times 7, 28. What is 2 plus 2? 4. So that's going to be d to the 4th, right? Okay, negative 12 times 7 is going to be negative 84, because negative times a positive is a negative, right? 1 plus 2 is d to the 3rd. 9 times 7 is 63, and that's going to be d to the 2nd, right? 4 times negative 5 is going to be negative 20, right? And then we got our 2 plus our 1. Remember, there's a 1 there, so that's going to be d to the 3rd. Negative 12 times negative 5, that's going to be positive 60, right? And we got our 1 plus our 1, right? So that's going to be d squared. 9 times negative 5 is negative 45, and that's just d. Okay, here we're doing 4 times 8, that's 32d squared, right? Negative 12 times 8 is 96, right? Negative 96. You guys can do these in the calculator, right? If you don't remember. And 9 times 8 is 72, right? Okay, so now again, we're going to be looking for our like terms in our diagonals, yes? So I don't see another d to the fourth, so I just have that one right there. So that's going to be 28 d to the fourth, right? Then I do see right here two negative terms, right? So negative 84 minus 20 is going to be minus 104 d to the third, right? Then we got our d to the seconds right here. Y'all see this? 32 plus 60 is 92, and 92 plus 63 is going to be 155. And that's going to be our d squared. Then we got our just d to the first. So again, we got two negatives. So we're just combining those two negatives, and we're going to get a bigger negative. So that's going to be negative 141d. And then we got the standalone term, that 72 right there by itself, right? Plenty of practice with multiplying, right, y'all? Okay. So the next one says, Archer's Ag STEM program is making a rectangular box vegetable garden. If the width of the garden plot is, so the width is equal to 2x plus 4, and the length is 3 feet longer. So the length is going to be 2x plus 4 plus 3. Isn't that going to be 2x plus 7? What is the polynomial expression for the amount of fencing needed to surround the plot? Ooh, I think I did this problem wrong. Did I? No, I didn't do this problem wrong. We don't need that box, do we? What is, if it's the amount of fencing needed to surround the plot, we got a length, right? We got a width, right? And a length, right? So can't we just go 2 times our width, which is 2x plus 4, plus 2 times our length, which is 2x plus 7, right? What do we do with this? We distribute the 2. 2 times 2x is 4x. 2 times 4 is 8. 2 times 2x again is 4x. 2 times 7 is 14, right? So then, don't we have these like terms right here? 4x and 4x is 8x, right? And 8 plus 14 is 22. That's our answer. Okay. This is our last set of problems, right? So are the triangles below right triangles? If so, why or why not? And if so, what is the statement that can be made about the sides, and where's the right angle? So my first question was, where do you think that this angle down here, Z looks so cute, so does Y. Let's check X right here. That's, I'm going to put a question mark there. So if there's a right angle there, it means that XY, this side up here, should be perpendicular to that side right there, right? So let's check the slopes, okay? So we're going to check the slope of XY. So we're going to go 1, 2, 3, 4 up. So that's 4 up. And 1, 2, 3, 4, 5, 6 over. 4 over 6, that reduces to 2 over 3. You can do that in your calculator, right? Okay. Now let's talk about the slope of the other side, which is our XZ. So we're going to talk about slope XZ. But wait a minute. Before we do, if the slope of XY was 2/3, what should the slope of XZ be if it's perpendicular? Negative 3 over 2. Now you guys can tell it's negative because the blue line's falling from left to right, isn't it? So let's just see what's happening. 1, 2, 3, 4, 5, 6 down. So we got negative 6 down. Looks good so far, right? 1, 2, 3, 4, 5, 6, 7. Ooh, negative 6/7. So there is no relationship between those slopes, is there? 2/3 and negative 6/7. One's positive, one's negative. We can see that, but they are not perpendicular. Not perpendicular, so there is no right angle, right? Okay, we're going to do the same thing with the next one. Okay, so again, if I'm looking at this, doesn't look like there's a right angle there. Doesn't look like there's a right angle right there. So I'm going to ask myself, is it there? So what are we going to compare? Once again, same thing. So notice YX right here is falling, right? Y'all see that from left to right? So we're going to talk about the slope of YX. So it is 1, 2, 3, 4, 5, 6, 7 down, negative 7, and then 1, 2 over. Y'all see that? Now, let's talk again. If these two lines here, this blue line right here, is it going to be perpendicular? What's going to have to be true of it if it is? It's going to have to be positive 2/7, right? Okay, so let's check the slope of this one. So the slope of ZX is going to be 1, 2 up. So far, so good. 1, 2, 3, 4, 5, 6, 7. Look at that. So can't we say that y-axis is perpendicular to z-axis? We can. Thus, what is there right here? There's a right angle where? At point X. And that makes sense, right? Y'all see that right there? There's an X in this one. There's an X in that one. And for there to be a right angle, the two sides of the triangle have to come together at that point.